Okay, looking next topic, further calculus. So we're going to look at differentiating and integrating sine and cosine. So f of x is sine x. When we differentiate it, f dashed x becomes cos x. F of x is cos x. When we differentiate it, f dashed x is negative sine x. Both of these are given on the formula sheet. So looking at them, differentiate the following. So f of x is 3 cos x, f dashed x is negative 3 sine x, because cos is negative sine. For f of x equals 4 minus sine x, f dashed x, the 4 disappears, remember. Normal differentiation rules apply. And sine becomes cos, so it's 4 minus sine x, f dashed x is just negative cos x. For c, y equals x minus 2 cos x, so dy by dx, x, remember, becomes 1. And 2 cos x, the cos becomes negative sine, so negative, negative, positive 2 sine x. For d by dt, thought I'd change up the variable, of 3 sine t plus 4 cos t. Sine t becomes cos t, so 3 cos t. Cos t becomes negative sine t, so the plus becomes a minus, so minus 4 sine t. Note, if we're using calculus and trig, we'll be using radians almost all the time. So the first one, find the equation to the tangent to the curve, y equals sine x, x equals 3 pi by 4. So we diagram of it, 3 pi by 4, second quadrant, somewhere about there. So exactly as we would have done with any of the curves we did previously, gradient, point, get the straight line. So gradient, we use the dy by dx equation. Point, we use the y equals equation if it hasn't already been given, which it hasn't. So doing the point first, y equals sine x is your original y equals equation. We bung in x equals 3 pi by 4. So sine of 3 pi by 4, 3 pi by 4 is 135. So your acute angle is 45. Sine's positive in the second quadrant, so it's 1 over root 2. So your point is 3 pi by 4, 1 over root 2. Your gradient, dy by dx. So dy by dx, sine x becomes cos x. At x equals 3 pi by 4. So it's the cos of 3 pi by 4, so cos 135. Your acute angle is 45. Cos is negative in the second quadrant, so it's the negative cos of 45, which is negative 1 over root 2. We already knew that from the graph, it's a negative. So putting it together, it doesn't matter, it's got nasty values in it. So y minus b equals m brackets x minus a. Y minus 1 over root 2 equals negative root 2 bracket x minus 3 pi by 4. Times through by root 2. So root 2y minus 1 equals negative x plus 3 pi by 4. Take the x over, bring the 1 back. X plus root 2y equals 1 plus 3 pi by 4. For next bit, show that y equals 4 cos x plus 2 has a minimum turning point at pi negative 2. So first things first, turning points, differentiate, stick it equal to 0. So we differentiate 4 cos x plus 2. We get negative 4 sine x, cos becomes negative sine. The 2 disappears because it's a number exactly as it would in normal differentiation, because this is all this is. Equals 0 for stationary points, so we need to be divide through by negative 4, so sine x equals 0. Where does sine x equal 0? 0, pi and 2 pi. So it's wanting us to look at pi. So our nature up to pi and away from pi, dy by dx. So if we go just before 180, we would say pi sine, second quadrant, sine would be positive. So we times it by negative 4, it'll be negative. After 180, just after 180, third quadrant, sine is negative. But again, we're times it by negative 4, so it's positive. So negative, 0, positive. So it's a minimum at x equals pi. And then we've got to check it actually passes through that point. So 4 cos pi, our original equation, plus 2. So 4 lots of negative 1 is negative 4. Add 2 is negative 2. So it is a minimum turning point at pi negative 2.